Welcome back. This is another exciting episode of Mr. Takeda's Teaching Math 7. This is 9.2 on surface areas of pyramids. What is a pyramid? Oh, those are those big things in Egypt and Mexico. Well, yeah, those are pyramids, but in terms of geometry, um, they can have any size, they can have any shape base, and then the other faces are going to be triangular. Let me show you here in a second. Boom, it's me again. So you'll see that this is a pyramid, but this one has a square base, but triangular faces. This is also a pyramid, and the faces are triangular, but they're all the same, these, but more importantly, the base is triangular, and it's not the same as these other faces. All right. So this one's an equilateral triangle, but the faces are not. Okay, they could be, but they're not. So if you look at the diagram, you can even have hexagonal-based pyramids. They can be any type of any polygon, but we're going to deal with some of the more common ones, triangular and square. Let's get started. Oh, also the slant height. We call this the slant height. It's basically to figure out the area of the face. We need the not the height of the vertex from the base. We need the height of the vertex from the base along one of the faces. We call it the slant height because it's along one of the faces. Okay, so let's take a look. So here's the surface area of a pyramid. And let me show you what this looks like. I'm going to unfold this one here for us to look at. Boom. So here's that triangular pyramid with a square base. Oops, sorry, with a square base. That's this one. Triangular pyramid with a square base. So when I unfold it, kind of looks like a star or a ninja throwing stars or something. So you see my square base, and then I have four identical faces. I have four identical lateral faces in this case. And the slant height is this height here, because that is the how we're going to figure out the area of that particular face. Okay, so let's find the surface area of this square pyramid. Okay, so we've got two dimensions that we're concerned with. We've got this square base that's has an edge of 5, so that's square. They're telling us that's a square pyramid. It's a regular pyramid. That's 5, 5, 5. So we know this the area of this base is 25, and then we've got this other 4. And again, when you draw this, remember these side lengths should be the same, right? All these side lengths should be the same because when they're going to fold up, they're going to join together along these edges here. If you happen to sketch this, now let's draw in the slant height here. They're giving us that slant height of 8. Why is that important? Well, because if I was to figure out the area of this triangle, it's 1/2 base times height. It's really the height of the flattened triangle, the face of the triangle. So 1/2 8 times 5. So 1/2 of 8 is 4. And so this is 20. So each of these then is 20. So my surface area, I can say, is 4 times 20. 420 plus 25. So 4 times 20 is 80 plus 25. So the surface area is going to equal 105, and this would be square inches. Okay. Want to pause and go back over that again to see how I did it. But again, hopefully you can do areas of triangles. Try this one. What is the surface area of a square pyramid with a base side of 3 meters and a slant height of 6 meters? See if you can come up with these areas. Okay, pause the video here to finish this one, and I'll join you on the next. Here we go. We're going to find the surface area of a triangular pyramid. So in this case, they're calling it a regular pyramid. What do I mean by a regular pyramid? They're saying that this base is equilateral. So let me show. Oh, okay. Here you go. Okay, so there's my regular base. It's an equilateral triangle base, and it unfolds. And again, it looks like this time. It looks like a bigger triangle. You know, these things aren't exactly straight. They don't have to be. They could be, but they're not. If this was an if all the faces were the same, it would be, but it's not in this case. And this the one that we're going to do right now isn't either. Okay, so let's orient it this way. We're going to do it that way. Okay, so I'm going to draw an equilateral triangle to the best of my ability. It's about equilateral 10 by 10 by 10. And then I've got this slant height of 14, so it's going to be longer than this. It's going to be about out to here, right? And again, all these are going to have the same kind of length to them. You know, all these sides out here will be about the same. It's just a diagram, so that doesn't really matter. Next, we have the slant height here of 14. Okay, so we have two different triangles we have to kind of figure out here. Let's do the base first. Now the base they're telling us has a slant height of 8.7. They're telling us it has a slant height of 8.7. Okay, so let's do that one first. That's going to be 1/2 times 8.7 times 10. So it's 1/2 of 87. And 1/2 of 87 is going to be 43.5. Okay, so we have a base of 43.5. Now, one of the lateral faces is going to be 1/2 10 times 14. So it's 1/2 of 140. So it's going to be 70. Okay, so let's add these up. My surface area is going to be 43.5 plus, I've got 3 of these that are 70, right? Let me label this so we can make sure. This one's 70, this one is 70, this one is 70, the one in the middle, 43.5. And I apologize for the sloppiness. 43.5 plus 3 times 70. So 43.5 plus 210. So this is going to be 253.5. That's my surface area. And again, these are in meters. So this will be meters squared. Okay. Okay, so you have to think all these sides separately. These three are the same. The base is different in this case. Try this one, and this will end the video, so you'll put the answer in at the end of the pod. And thanks a lot, and have a great rest of your day.